Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad. My ID is 003 and my department is chemistry, first semester. And today I'm here to present my presentation and my presentation topic is reduction in organic chemistry. Let's forward. So first of all, we will see about what is meant by the reduction in organic chemistry. Basically, it is any process in which there is an increase in the number of covalent bonds between an atom and that atoms which are less electronegative, and it is commonly seen that but not limited to increasing the number of bonds between carbon and hydrogen. If we talk about the example reactions of reduction in organic chemistry, the first reaction is catalytic hydrogenation. In catalytic hydrogenation of propane is a reduction because there is an increase in the number of bonds between the carbon and in its electronegativity is 22.5 and hydrogen electronegativity is 2.0 2.1. And now move forward. If we talk about reduction, it is stated that the species that gain electrons is called reduction. The passing of one or more electrons from one species to another. For example, in sodium, in dichloride, add two electrons, then it forms two chloride, and in sulfur, if we add two electrons in sulfur, it forms sulfur. That's right. So, if we discuss about the types of reduction, there are five main types of reduction: combustion reaction, decomposition reaction, displacement reaction. Fourth one is combustion reaction, and fifth one is disproportion reaction. Now we talk about the combustion reaction. Combustion reaction in which two or more reactants combine to form a single product is known as acceptable combustion reaction. Its general equation A plus B will give us AB, and it is also known as synthesis reaction. For example, in which two sodium atoms react with two dichloride and form two NaCl. And if we talk about the second types of reduction is decomposition reaction, a reaction in which a single compound breaks into two or more simpler compounds is known as decomposition reaction. And its general equation of formula is AB will give us A plus B, which separate the reactants into two forms. For example, calcium carbonate react and form the calcium oxide and carbon dioxide. The reaction in which a compound decomposes due to heating is known as thermal decomposition reaction. Now, if we talk about the displacement reaction, the third type of reaction, it is stated that the chemical reaction in which one in which a more reactive element displaces a less reactive element from its aqueous salt solution. Its general formula is X plus YZ will give us XC plus Y. And it is also called substitution reaction. For example, zinc react with copper sulfate to form zinc sulfate and plus copper. It is also categorized into metal displacement and into non-metal displacement. We will talk about it is categorized into metal displacement and into non-metal displacement. So we talk about what is metal displacement. In this type of reaction, a metal present in the compound is displaced by the another metal. For example, is the reaction in which copper sulfate reacts with zinc to form the copper and zinc sulfate. Here we can see the in which sulfate react with zinc to form zinc sulfate. Now, if we talk about non-metal displacement, in this type of reaction of hydrogen displacement and sometimes rarely occurring reactions involving oxygen displacement. Now we talk about the fourth type of the reduction is disproportion reaction. The reaction in which single reactant is oxidized and reduced is known as disproportion reaction, which phosphorus plus sodium hydroxide plus water react to form the sodium hypophosphite plus phosphate. Now we're going to talk about combustion reaction, fifth type of the reduction. In combustion, the oxygen is reduced and the other element oxidized. Basically, in this reaction, energy is flow of heat is usually given off as a product in combustion reaction as well. In this, compound react with oxygen and produce carbon dioxide, water, and heat. Here we will see about the reducing, some reducing agent. All metals are reducing agents such as sodium, zinc, iron, aluminum, and to non-metals carbon, hydrogen, sulfur, phosphorus, and some are hydra acids, HCl, HBr, H2S, and compounds containing lower oxidation state are FeSl2, FeSO4 plus, and SnCl2, and organic compounds like HCOH. When we talk about the reduction reaction, we will see the two reactions. In the hydrogen react with fluorine to form the hydrogen chloride. Uh, Fluorine is basically act as a reduction, and hydrogen is act as hydrogen oxidized and fluorine reduced. And in this second reaction, zinc react with copper sulfate to form the zinc sulfate plus copper. In this reaction, oxidation state of copper sulfate reduced and zinc oxidized and form the zinc sulfate and copper. Now we'll talk about the mechanism of reduction. So here we now talk about the Kilimanjaro reduction, Wolff-Kishner reduction, and batch reduction. The three mechanisms to define the reduction in organic chemistry and so on. So first of all, we talk about the Kilimanjaro reduction. In this reaction, Kilimanjaro reduction. In this reaction, carbonyl compounds such as aldehydes or ketones are reduced into alkane by using zinc, amalgam, and hydrochloric acid. Amalgam is basically alloy with amalgam is said to be alloy with other metals such as zinc, mercury. In the carbonyl compound react to form the alkane in the presence of zinc, mercury, or the concentrate of HCl. In Kilimanjaro reduction, the resin zinc amalgam work while powder of zinc metal does not. Is that metallic zinc is activated by mercury by dissolving it into individual atoms of zinc that are distributed evenly in the alloy. So zinc perform in this reaction as it is solution of zinc. Ever see the mechanism of a Kilimanjaro reduction? Activation of the carbonyl compound by the concentration of HCl. So here the carbonyl compound is left electrophile, and the H plus react with oxygen uh, uh, um, react with oxygen, and we get this structure. In this pi bond shifted on oxygen. Um, in this H react with oxygen, bond with oxygen, and here um, in this the carbonyl compound, the double bond between the carbon and oxygen. The carbon, the pi electron shifted on the oxygen, and we get this structure. In this, and it called carbocation. In the second step, zinc react and divide into zinc that then 2 plus and 2 electrons. It mm, so, so we are here discuss the activation of the carbonyl compound. In the sorry for the disconnection my net problem here. So we were discuss the activation of the carbonyl compound. In the second step, zinc zinc react and form the zinc Zn2 plus plus 2 electron, in which the zinc in which the zinc produce 2 electrons, and with these 2 electrons react on the these 2 electrons react on the carbocation, and we form the structure. In this structure, we get a carboanide. So these two by these two ion provide ion to OH and to the carbon anion to and we form this structure. In this structure, in this structure, OH evolved, and we get this structure in this and we get this structure in that structure, and we form the electrocation, in which the zinc again get and form the 2 electrons, and these 2 electrons react with the carbocation, and in which the production proportion reaction occur, and we finally add and we form the alkane, in which the we form the alkane from the carbonyl compound to alkane. And the second one is Wolff-Kishner reduction. In this reaction, carbonyl compounds such as aldehydes or ketones are reduced into the alkane by using hydrazine NH2 bond NH2, in which the carbonyl compound are used to form the alkane in the presence of hydrogen ion and calcium hydroxide. In the preparation, in the first step there is preparation of hydrogen in the carbonyl compound, in which uh, carbonyl compound react with uh, hydrogen and the water evolved, in which they to form the hydrazone, in which there is a double bond between the carbonyl compound and nitrogen. And in this step two, this hydrazone uh, um, in this step two, this hydrazone. So in this In the second step, we will talk about in which the abstract potassium hydroxide abstract the acidic protons, and we get this structure. In this, the negative charge on the nitrogen, uh, divides proton between the nitrogen, and here the double bond shift pi bond shift on the electron break, these pi bond break, and we form this structure in a carbo and we form the carbo anion this structure, and again the abstract again the carbo anion abstract the partial hydroxide hydroxide abstract, and we form this structure. In this structure, here the OH had the negative charge on the OH or potassium hydroxide. On the, so again the abstract and these acidic protons, and there is a abstract protozoan, and here the negative charge on the nitrogen. There is a double bond between nitrogen, and when the nitrogen donate its proton between nitrogen double bond. So here the single bond between the carbon and the nitrogen break, and nitrogen evolved. When the nitrogen evolved, there is we get the carbo anion. Again, the carbon anion abstract the carbon abstract, and at the end we form the alkane. So here the process to form the hydrazone to alkane, or carbon alcohol to alkane, formation of carbon alkane. And the third one is Brett reduction. In this reaction, aromatic ring is converted into non-conjugated 1,4-cyclohexadiene in the presence of sodium, lithium, calcium metal in the liquid, and NH3 and alcohol such as ethanol or tertiary butanol. Here we see the benzene ring react to form the 1,4-cyclohexadiene in the presence of sodium, lithium, calcium in liquid form, and methyl alcohol or butadiene. Here the mechanism is there is two steps. In the first step, sodium react and form this sodium and plus one electron. In the second step, benzene plus react with one electron. In this, the one electron react on these carbon atoms. So here the three carbon double bond in this structure. So we were talking about the mechanisms of reduction. We were on a second step two, in which the one electron react on the carbon on these benzene these carbon atoms. So here the three double bonds. These double bond break and shift on these carbon atoms. As we move forward, here on this carbon atom there is a negative charge, and on this carbon atom is a unpaired electron. So there is a double bond homogenetically. These double bond are homogenetically break, and donate its electrons between these carbon atoms. So this carbon atom and the carbon atom form a bond in the resonating form. So in the we get this structure. In this structure, there is two double bond, and here we will the negative charge and unpaired electron. So again there is so there again double bond homogenetically donates electrons between the carbon atoms, and we form the structure. So there is a this unpaired electron moving in the benzene rings. The second structure is more stable because negative charge and the negative charge and unpaired are the maximum distance, so the repulsion will be minimum and stability increase will be maximum. So this structure is stable, more stable than the others, so it move for further direction. So in so talk about in which the sodium there is a negative charge on this benzene ring at the H plus ion from the ethyl alcohol, H plus ion from the ethyl alcohol act as a protonol and react on this carbon atom, and we get this structure. In this structure, again, the sodium lose one atom uh, and, um, and we form this structure. There is again proton reduction, and these react on these carbon atoms, and finally we form 1,4 cyclohexene. Here the mechanism from the to form the 1,4 cyclohexane from the benzene. So that's all from my side. Uh, Thank you so much.